So, hello. That's quite a lot of you coming to hear about Make. That's turned off. That's no good. OK, watch that. So, this is going to be a 101 talk. It's going to be quite basic. I'm going to go through the steps of building up a decent Makefile, do some stuff. If you already know Make and you're an expert, then I apologize. Please do go next door and see something more interesting. So I'm Rob Ashton. If you've tried following me on Twitter from the page on the site, it's not spelt like that on there, so you're now following some random agile consultant in London. I'm not him, so don't send abuse to him on Twitter, because he'll be very confused. Send abuse here on Twitter, and I'll know what we're talking about. This is me. These are things I don't like, quite a lot of things. These are things I do like, just to give context for this talk. That is to say, I don't like very much. Some context. I work in a team of predominant Erlang developers. They're all a bunch of beard-wearing Emacs users. We have a lot of C, a lot of Erlang, and therefore a lot of Bash and a lot of Make. Our C and Erlang are largely polished diamonds, and they're wrapped up in duct tape, where that duct tape is pretty much just Bash and Make. Because of this, it made sense to use Make for our JavaScript. It may not make sense for you. I'm not evangelizing up here, although I kind of am, because I haven't yet seen a tidy, nice Grunt or Gulp file. So, Make. I found this picture on a Make website. I quite like it. It's apparently it's a new, or however you say it. I don't know. Looks like it was drawn by a 3-year-old. It was drawn by a 30-year-old. I really like it. So Make is as old as the hills. It really is old, but it means it solved all the problems, and it has solved all of the problems in weird, wacky ways, which makes it super fun. And I always kind of established that if you're using cowboy languages like JavaScript, and JavaScript is a cowboy language, you may as well use cowboy tooling around that and keep things fun, keep things living a little bit. Trying to be all professional and use like really shiny build tools like Grunt or Gulp, and arranging everything into tidy, nice streams, and arguing about semicolons is all very, very fun. But it's not as fun as wading through obscure symbols and traversing weird dependency graphs in Make. I really enjoy this, and I find it very entertaining. So yes, that's why I Make. So I'm going to jump right into what Make is and do some demos, because that's more exciting. And more importantly, what Make is not. So over here in this directory, I've got some stuff. I haven't got any cool music to play. You can hum if you want to, whatever. You can just do a little dance, but to use imagination for now. So I've got a recursive vars Makefile over here, which hasn't got anything in it. I just want to demonstrate that Make is not procedural. So here I'm going to make a variable and assign it to whatever the value of 2 is. I'm going to make another variable and assign it to whatever the result of 3 is. And I'm going to say 3 is equal to hello world. And then down here in the all target, I'm going to actually make that even bigger so you can all see it. That all good at the back? Yeah, we're good? OK, cool. I'm going to echo out whatever is in the value of 3. And if I run this, so over here, we get hello world printed out, which is quite interesting if you are reading that top down, one at the bottom. All these variables are lazy. They're evaluated at a point of actual using. It's called expansion, variable expansion. And these are recursively, actually, I got that wrong. These are meant to be them. Oops. OK, whatever. Forget everything I just said. So if I go into simple vars over here, you also have these ones. And we have a semicolon in there instead. And these are actually evaluated at the point of time, which means in my all over here, if I echo out the value of 1, oops, that should not have worked. I've done everything wrong. I'm having demo fail already. That's pretty exciting. Oh, yeah, oops, I meant to do that. Yeah, quite. So anyway, because of this colon over here, these are evaluated at the point of execution, which means the value of 1 at this point over here will be nothing prints out. This is kind of important. Make is all about expanding expressions. Those expressions might be simple variable assignments, or there might be function calls to go and get lists of crap. Not really important. What we have is a very non-procedural language. Recursive variables are really lazy, and simply expanded variables are not. But simply expanded variables are really a new Make thing, and they're not in all flavors of Make, so whatever. I'm going to use recursive variables absolutely everywhere in these demos. So what is the structure of a Makefile? What does it look like? Well, it's separated out into these things called targets, prerequisites, and recipes. I'm trying to use a terminology that I use on the site. I tend to call it a big pile of Make and get on with life, but that's not for everyone's tastes. So over here, I've got a very simple setup in a directory. There's a simple copy. Okay, we have a Makefile, and we have an in directory. In our in directory, we have a file called pinky.txt, where Pinkie Pie is the best pony. And we have a file called rainbow.txt. Rainbow dash is not best pony. This is a truism. Everyone knows this. If you don't know this, you do now. I hope you have an opinion on that. Please do. And we have a Makefile. Right. I'm actually going to copy and paste from down here rather than try and write things, because I think I'm in a demo fail mood today. This is preparation, this is. Right. So what I'm going to do over here is I'm going to define a target. My target here is a directory called out with pinky.txt in it, and that's got a dependency on in/pinky.txt. It's also got a dependency on out, which is nice. Could you copy and pasting that? That'd be good. The recipe is the contents found underneath this. So here I've got in pinky.txt and out pinky.txt. And here we'll do the same thing of rainbow, and down here we have a target called out, which is a directory, and we simply say, please make the directory called out. Over here, we're just echoing to dev null, because all doesn't do anything. If I run this, so I go to simple copy, and say, hey, please make that. We'll see here it copied over my pinky and rainbow is the output directory. And if I run it again, it didn't do anything at all, because Make's quite clever. And when you have these targets set up and dependencies set up, it looks at the files, it looks at the timestamps, it only does things where timestamps are different from what it expected, which is nice. Because if I go into in.pinky.txt and say, Pinkie Pie is definitely the best pony, because I want to remove any ambiguity, and I run make again, it'll only copy pinky.txt. This is like the best thing about Make, which is if you set up a decent dependency graph, it will be very clever about what it runs or what it doesn't run, which is all very nice and shiny. I believe that was the only point I wanted to make here, really, which is we can do copying of Gulp. So that's nice. We have a target, we have a list of prerequisites, and the prerequisites execute from right to left. Got that? Of course we did. Excellent. So what we learned here is targets are usual actual output, physical outputs on the disk. Prerequisites can be either files or other targets that need executing. And recipes are just simply scripts that execute to make the targets appear from those dependencies. Nothing too exciting. Of course, that Makefile is utterly crap. I can't sit there and write a Makefile for every single file in my input directory and every single file in my output directory, because that would take me all day. So we have these things called pattern rules. Let's go and do a demo of that, shall we now? So let's go to my pattern directory. So here I have the exact same Makefile I just made before. That's the wrong keyboard shortcut. I'm normally a Linux user, so I just closed that terminal rather than actually doing things in Vim. That was very clever of me. I'm just going to pretend that didn't happen and go over here again. I don't know my keyboard shortcuts on macOS, I'm afraid, so I make a mistake all the time. OK, carry on. So here we have a really crap Makefile, because we're actually copying files independently all the time. We can actually use pattern rules to do this and say, well, actually, if we call a target where it's any pattern matching out/something.txt, then actually our dependency will be in something.txt. And down here, we can actually take the value which we've got from above, which will be it's an angle bracket, of course it is. The incantations are important. I want to copy from here. Wrong keyboard shortcut again. I'm not really confused when on macOS that the control key is in the wrong place. Always gets me. So, isn't that exciting? We can say, this is a magic automatic variable given to us by Make that says, whatever the target is, please put it in $open angle bracket. And the other one, $at, is whatever our first prerequisite was. We still have up here all out/pinky and out rainbow.text, but they will actually both pattern match on this target over here, and they will both work. So if I go and run that, so over here I say make, that actually worked, and it expanded to pinky and rainbow, and it works just like it did before, which is super awesome and nice. So we saw here something really nice, which is we have pattern rules, where we have substitutions with that lovely percentage symbol. Automatic variables are then exposed to recipes from both the targets and the prerequisites, and we have a nice long list of magic incantations that will get things out of that list. You start reading the magic incantations, and they start memorizing them. Clearly, I've forgotten because I'm on stage and I'm panicking, but there's like a dozen of these, and it makes your Makefile really pretty to read because no one has a clue what's going on if they don't know Make, which means when you're in a coffee shop and people look over your shoulders, they think you're dead clever, which is awesome. So Make has a bunch of built-in functions which you can execute for evaluation. And I'm going to go and do that now. Demo, wildcards, very exciting. So the thing that's wrong with this Makefile currently, I don't really like, is that over here I'm having to do out/pinky and out/rainbow as my actual targets. I'm having to do them explicitly. Well, that's kind of crap because I don't want to write out all of my targets manually in my Makefile. It's rubbish. So instead what I can do is I can call functions, and I'm actually going to do that over here as inputs. I can generate a list of inputs down here and say, well, actually, if I call this function wildcard and match on anything in the indirectory, asterisks and text, please put that in a variable called inputs. Thank you very much. Well, that's not very useful because, of course, I want to replace out/pinky and out/rainbow over here, and currently I have in/pinky and in/rainbow, which is completely useless. So I can call I can call another function on my inputs, just over here. Oops. Oops. Oops again. There we go. And I can say, actually, could you do a pattern substitute on in/whatever and replace that whatever with out/whatever on all those inputs? And now I've got a list of outputs. I can actually print out this list. I'm just going to hide this entire line from now. So, and say, I'm going to echo out my outputs. And for good measure, I'm going to echo out my inputs as well. That's a printer. That's no good. Did I mention I don't know my keyboard shortcuts on macOS? I'm hitting all the wrong keys constantly. It's actually quite embarrassing. So if I run this Makefile, you'll see here that my output list contained out/pinky and out/rainbow, and my input list contained in/pinky and in/rainbow, which is super cool. I've generated a list of files, and then I've replaced some expression in those files with something else. And now I've got two lists of files, which are my inputs and my outputs. And what that means is I can feed these outputs into my target over here as a dependency, and that will match against this out/percentage.text, and I'll execute this rule for everything in that outputs collection. These inputs over here aren't actually used apart from to build this outputs collection. Obviously, in other examples, you might choose to do that. So I'm just going to echo to Devnall here again. I just like to do that. I don't like to print crap out. So if I run this now, that actually executed, and I copied over my pinkies and my rainbows to my output directory, and we can see that very easily, because if I cat out/pinky and cat out/rainbow, we see that Pinkie Pie is still best pony and Rainbow Dash is not best pony. Quite firm on that opinion, by the way. So we learned here that we can generate lists of inputs using wildcards against things on the file structure, and we can generate lists of outputs by then pattern substituting on that list, which is really cool when combining that with pattern rules. And this is basically what happens in nearly every single Makefile you ever build. You go and you scan your folder structure, which is a known folder structure for all the files you wish to input into various command line tools, and then you generate the outputs you probably want to expect out of that, and then generate a big pile of targets off that, and you run all your code, and hopefully you end up with a compiling application, which is super cool. So this is why Pinkie Pie is best pony, by the way, because she plays all the instruments. Fucking awesome. I'm going to put this together now. I'm going to build something that's roughly equatable to a real-world example. It's not going to be a real-world example because I don't want to sit there and start playing with Browserify and NPM and Reactify and everything else I might choose to use in a JavaScript application. So I'm actually going to go incredibly vanilla right now, and this is not going to represent how I actually do things in the real world too much. but I didn't want to start throwing in all sorts of crazy concepts. So over here, I've got a simple widgets directory. And in my simple widgets directory, I have, wrong keyboard shortcut again, never mind. I have a widgets folder. In that widgets folder, we have 3 widgets. One's called Celestia, one's called Pinky, and one's called Rainbow. And each one of these has both a stylus style sheet of some sort, have some kind of index file, let's say index.coffee or whatever, and they've got some images too. So there's pictures of Celestia as a child and Celestia as a grown-up and whatever. And they're just widgets, and I don't want to know what those widgets are actually composed of, but I have a convention in my project that all widgets have some kind of index entry point and some kind of index for style sheets or whatever. And what I want to do is I want to copy all that across so this index file will actually work. So over here, I'm referencing widgets.css and widgets.js, and these functions are magically appeared that I can invoke over here. Obviously, in a real world, I'd probably use browserify, but actually compile things beforehand and pass them through, but whatever. This is a nice, simple example. So I have 2 outputs here at least, which is widgets.css and widgets.js, but I also have images in these widgets folders, and they need copying across somewhere as well. Again, in a real project, we might want to put them in an image map, but we're not going to do that today because it's pretty crazy. So here I've got a Makefile, which is quite ambitious, but thankfully I paired it all down here before. So I'm going to copy and paste everything again. Absolutely wonderful. So the first thing I always do when making a new Makefile is I think about what my outputs are, and I start at them. And I work my way up. So it's quite clear that I have 2 outputs over here. And these outputs are going to have to be they're completely wrong. Got the wrong file open. There we go. Wow. OK, good. So here I want to say I want to make a widgets.js, and I want to make a widgets.css. And clearly, I'm going to need some JavaScript files to concatenate into this thing over here. And I'm going to need some CSS files to put into that thing over there. So how am I going to get those? Well, let's go to the top of our file over here, and let's go and get some expansions. So if I have some coffee files in each widget over here, I'm going to wildcard against widgets / whatever the name of the widget is, and then anything that's coffee in that directory. And I'm going to generate a list of output.js files from that by pattern substituting and placing all the coffees with JS's, obviously, as you do. I'm also going to do the same with stylus files. And I'm going to say, well, actually, I want to take all the stylus files from that directory over there, widgets / whatever style. And I'm going to say my output CSS files are going to look like that with the style replaced with CSS. Make sense so far? Of course it does. Nothing complicated here at all. I hope not, anyway. OK, cool. So I'm going to focus on CSS and such for now. What I need to do is I need to somehow convert all my JavaScript files across to my coffee files across to JavaScript files before concatenating them. So for that, we need a compiler. Well, obviously, that's going to be the CoffeeScript compiler. So if I gather up all of my there we go. If I gather up all of my coffee files over here as dependency, so widgets / whatever coffee, and I have a target of widgets / whatever JavaScript, it's quite clear all I have to do is execute CoffeeScript compiler against the target I want to generate, which will work perfectly fine. It's also quite clear that if I want to generate a pile of widget.css's, I can do the same thing, which is nice. So now I can make a big pile of CSS files over here, taking in the stylus files and getting some outputs, which is super cool. If I want to execute these rules, I'm going to have to say, well, actually, let's make 2 placeholder rules over here. Let's say we have style and we have coffee. These style and coffee, by the way, go intrinsically hand in hand. If you haven't got coffee, you haven't got style. So here we go. Output CSS files requires site widget CSS. And output CSS files does that thing over there. So that's all wonderful and fine. So here, if I call coffee, it's going to look at the output.js files. It's going to match against this rule for every single JS file. And it's going to go and look at all its coffee files. And it's going to execute CoffeeScript, compile it against any file that has been changed in recent times, which is nice. So if I go over here and I want to generate my code, I can say over here, well, if I want to do the code, I want to execute the CoffeeScript compiler, and then I want to make the widgets.js file. over here. So over here, we'll, oops. Uh-oh, there. I'm confusing myself here, the copy and pasting. I hope you're following, because I'm not. OK, cool. So to make site/widgets.js, we take all the JS output files, and we cat them all together in a really horrible way. So I hope there's semicolons in those files. Obviously, there will be semicolons using CoffeeScript. Thank heavens for that. If there wasn't semicolons, because some kind of hipster, then this wouldn't work. Friends don't let friends, don't use semicolons. I'm actually going to make a clean directive over here just because it's polite. It's good to be polite. Let's delete the images for now, though. Cool. I'm going to say my all is going to depend on my code, and it's going to depend on my style, as you'd expect. I'm going to echo this down to dev/null again. Cool. So what we've done is we've gathered up all the CoffeeScript files in all my widget folders. We've generated targets for them, which are JavaScript files in the same folder. And then we've made another target, which is the output JavaScript file, which depends on those things over there. And we have a nice pipeline of individual files to one big file, which is super cool. And because I don't trust any of my copy and pasting, I'm just going to copy and paste all this over here. There we go. There you are. Let's pretend I live coded all of this. So I'm going to copy all of my CSS across into one file, my JavaScript into one file, everything's wonderful and fine. I can run this over here. And we see here it ran my CoffeeScript compiler against all my JavaScript files. I did everything like that. Everything's wonderful and fine. If I run make again, it does nothing at all, because nothing needed to be done, because nothing's changed, which is super cool. I'm going to do a make clean now and show you something really awesome. One of the great things about make is once you have all these targets set up and you're doing things on a file-by-file basis, this is important, it's very easy to parallelize, because it has it built in. You can say make/j, and it goes and parallelizes all of that, and does everything really, really super quickly. You get this for free. So basically, if you build a sensible, composed Makefile comprised of lots of small targets and small files, and it's very granular, you can get a very build-fast process out the gate by just parallelizing it for free, which is super nice. By the way, the site I've made is really quite funky, so better look at that. There's my HTTP server. If I go to Safari or Chrome or whatever, I've got this on this machine. There you go. I've got Pinkie Pie, Rainbow Dash, and Celestia. And if I click on these guys, they change or whatever. And these are my widgets. They're very awesome widgets. They have ponies. You click on them, they do things, which is super cool. That's the most exciting thing I've written all day. OK, cool. So we'll see here that we have a widgets.css and a widgets.js and an image directory of everything copied across, which is super cool, because I've made a Makefile that does that for me in a nice granular way. Now, the thing is, this is kind of cool. You have a Makefile, which you've set up and composed very well. We have some placeholder files lying on the place to do timestamps. And we have automatic parallelism, providing you're on a sensible operating system. Clearly, if you're on Windows, none of this works, but I don't really care about that. That said, this Makefile is not perfect. Obviously, in a real world, we'd probably use Browserify against those compiled JavaScript files. We'd probably re-execute make on a per widget basis, so you could do more explicit pattern matching on things like dependencies for stylus files. And we'd probably, instead of have a widgets folder, we'd probably pattern match on the node modules folder. And in fact, that's what I do at my workplace. In all of our widgets are just node modules that contain all the JavaScript, all of the CSS, and all the images. We pattern match against the node modules directory. We pull those things out, and we can build image maps. We can output the CSS and output the JS and everything in parallelize. And it really is super fast, because only things that change get copied across, which is awesome. Quite a lot of stream-based pipelines kind of forego that, because you end up gathering all the files together and putting them through a stream, and it gets quite complicated and hard to understand. Makes quite complicated, but also incredibly simple. So, reuse. I've spent all this time making an amazing Makefile. OK, in this case, it wasn't an amazing Makefile. It was quite simple. But my work one is probably 500 lines of make. And I want to reuse that across all my projects, because all of my projects have a fairly similar structure. How do I go about doing that? Well, let's go and look at that, shall we? What I've done is, onto GitHub, I've actually pushed this repo, and there's an assets folder over here where I've got a common.muk. Nothing's changed in this Makefile from the one I just showed you, except for over here we have a conditional assignment of widget_dir to widgets. So if widget_dir has been specified by the caller of this Makefile, we'll actually not assign this variable. So in my current project, I want to call widgets gadgets or baubles or something, I don't know. And the other thing over here is I set the default goal. So when I invoke this, I will always call all unless I specify the goal myself. What I can then do is inside my inside a Makefile on an actual project, that's empty because I meant it to be empty, of course. There we go. Clever. We can export some configuration for that. So we can say export widget equals baubles. So by exporting it, it's available to other Makefiles that we invoke from this point. And then we can set a target of common.merc and say, well, actually, if we haven't got a common.merc, go and get it from GitHub by doubly getting it. Thank you very much. And then we can include common.merc, and that all works. And this is actually what all of our Makefiles look like at work. We basically have a bootstrapping Makefile which downloads a latest version of our Make and goes and gets it. And if I run this right now, it'll hopefully, if I'm on the Wi-Fi, there we go, it downloaded the Makefile into common.merc, and it executed against its baubles directory and gave me a site which was vaguely sensible. So there we go. There's baubles.js, baubles.css, and index.html. I'm not going to bother doing them of that because it's exactly the same as before. It's just ponies. I say just ponies. I'm very fond of ponies, so there's no such thing as just ponies. They're kind of awesome. So we learn here, for bootstrapping our Makefiles, wget is our friend, or curl, or whatever you like. We can export variables from Makefiles, which is super cool. You can set default goals, which is kind of useful because otherwise nothing will happen. And if you have a set of conventions across your projects, you can reuse Makefiles across all your things and get much joy and happiness from your life, especially as your Makefiles look very pretty. So here's a friendly warning of something not to do. This is what I see quite a lot with Makefiles. I see this a lot on GitHub, which really sucks. What we do is we use Make as a task runner. So we have some targets there called build.js and build.css, and they simply invoke some command line against an entire directory of JavaScript and execute all that stuff with some kind of templating thing or whatever. And then we have to set up phony directives down there to say, well, actually, those aren't real outputs. Please execute these things every single time. And basically, Make is being used as a task runner. And I see this a lot, not just in Node projects, but in Erlang projects as well. Like one of the most common Makefiles for Erlang is basically a glorified bash script written in Make, which is really quite atrocious because it's really slow, because it's not doing any conditional compilation. It's not going, is that beam file out of date? It's just compiling every single beam file, which is completely useless. So it is important to note, build systems are not task runners, and vice versa, not true. One of the mistakes I see, I think one of the problems I see all the time, is that Grunt and Gulp are being used as like a combination of both these things, and that's why they get so hairy and confusing. Most of the time, if you just want a task runner, well, that's what npm scripts is for. Just stick a bunch of bash scripts in there, and Bob's your uncle. Or in my workplace, it's a bunch of bash scripts calling a bunch of bash scripts because we're a bunch of cowboys, and that's what we like doing. But whatever, it's bash and bash and bash for doing task running, and Make for doing all compilation. These two things go together very well. Choose your tools wisely. That's it, and I am running out of time. I was right about having to rush myself a little bit. So if you want to come and tell me how awful this was, do so outside over a coffee or a beer. Remember, do not send abuse to Rob Ashton on Twitter. Send it to Rob Ashton. Two very different people. He will not appreciate that. Thank you very much. That was Make.